Today we're going to be graphing polynomial functions, starting with our zeros. Now, some of the information we learned in the last lesson, talking about end behavior, zeros, how many turns a function can have. We're going to think about some of that stuff when we're sketching our graphs. Before we were given the graphs, now we're going to be expected to sketch them. Now, say we start with the function x to the third plus 5x plus 12 equals 0. Remember, these always have to equal 0 for what we're about to do to work. Now we're going to factor this. And this is going to be another topic in a future lesson. So this is what I'm going to be giving you. Okay, we kind of start from this, but I'm going to give it to you in factored form. Now, as you remember, anything x to the third power is going to have up to 3 zeros, possibly 2 turns, and we have to think about the end behavior. As we look at our factors, I see 1, 2, 3 x's there. So that means it's a degree 3. That's an odd degree, and all of these are positive. There's no negative x's there, so it's a positive coefficient, which means it's going to start down and finish up. This is very important to know, to be able to identify right from here. Now, from our zeros, from these points, I need to establish my zeros. We're setting each thing in parentheses, each one of the factors equal to 0. So I'm going to go x plus 4 equals 0, x minus 1 equals 0, and x minus 3 equals 0. To solve these, add negative 4 over here to get x equals negative 4. If you notice, it's always going to be the opposite sign here in solving this. Right? Add 1, 1 minus x equals 1. Add 3 here, and the other 0 is 3. So I can start sketching this. I know I have a 0 at negative 4. I know I have a 0 at 1 and at 3. Now again, let me stress sketching. I do not care that these are perfect increments or anything like that, because some of our high points might be really high and I probably have to climb through my roof here and keep going in order to plot those points, or dig down deep in order to plot the low points. These are just sketches. Now my end behavior. I start down. So I know it's coming here, and I'm coming up at this point. Again, left to right, it starts down. Now, at some point, I don't know what it's going to do between here and here. I know it's going to come to these 2 points, but I don't know. So I'm going to pick a point somewhere in the middle. I can either pick negative 2 or negative 1. At this point, it doesn't really matter to me. So I'm going to pick negative 2. And I'm going to plug this point into my equation here. Now, if you want to use a calculator, you can plug in. Put in parentheses negative 2 plus 4. Close your parenthesis, open a parenthesis. Negative 2 minus 1. And then negative 2 minus 3. You can plug this straight in your calculator, hit equals, and you will get a number. Now the number I got was 30. So at negative 2, somewhere up here in 30, it's going to make a turn. Somewhere up there, it's got to come down now. If I put negative 1 in, another point, I get 24. So I know it's coming down. There's 30, here's 24, it's coming down through here. I want to know what it's doing here now. The point between 1 and 3 is 2. So when I plug 2 in, I end up getting negative 6. And here's 2, negative 6 about there. It then turns up, and I finish going up. Here's my graph. Starts here, comes up to a high point somewhere around here, starts coming down, a low point around 2, -6, and then up. My relative max, my relative min, those aren't perfect, but they're relatively close. Close enough for what we're doing right now. Later on, we'll be able to find those, but right now I'm not concerned with that. I'm just concerned that you get the shape of the graph. It starts down, starts going up, then comes down, then goes up again. So let's look at another problem. Again, I'm not starting with the original, I'm just starting with the factored form. And what we're using is called the zero factor rule. Okay, because anything inside those parentheses, because it's being multiplied, it turns out to be 0. Remember, if it's 5 times 7 times 15 times 192 times 0, answer 0. So let's look at this one here. We start with x plus 4, x plus 1, x minus 2 equals 0. Now again, I have 1, 2, 3, 4 x's here, 4 factors. So my degree is 4. They're all positive, so this means it's up and up. So it's going to start up here, end up here. Because I have 4 different factors. Now what's going to make this equal to 0? It's all by itself. So that one is 0. Plus 4 means this one's -4. Plus 1 means that's -1. Minus 2, which means this is a positive 2. So here's my zeros. I have 1 at the origin. I have 1 at -4. I have 1 at -1. And I have 1 at 2. So I know it's starting up, which means I'm coming down this way. And I know it's finishing up. So here's like the bread of my sandwich. And I have to figure out what we're putting in our sandwich. All the different turns. So again, I'm going to pick a point. And I picked -2. So I picked this point right here. And when I plug -2 and I got -16. So I know I'm down here somewhere, -16. I now know it's going up some. Now here at -1 and 0, what's between -1 and 0? -0.5 or -1/2. When I plug that in, I get 1.3. Just a smidge up here. Then guess what? It's going to make a turn back down here. There's my little turn. I'm now going to pick the number 1, which is right in the middle here. When I plug 1 in, I get -10. So again, this one was like -16. Here I'm at -10. So when I come down here, again it makes another turn, and it finishes up. So again, there were 3 different turns here. I had to find something in between here, something in between here, and something in between here. And those somethings were -2, right there, -1/2, and +1. We're going to do one more. This one's a little bit different. This is what you have to think about when you're thinking about how many zeros we have and how many factors there are. And this one's going to do something a little bit different. So here's number 3. We have x plus 1 squared. We didn't have that before. X minus 2, x minus 4, all equals 0. So again, first of all, we have to think about our end behavior. Now, here, this is squared. If I multiply this out, this is going to be an x squared. So there's actually 2 x's here. There's a 3rd x here and a 4th x here. So I have a total of 4 factors. So that's degree 4. And again, it's positive, so it's degree even. So we're going to finish up and up again. However, I only have 3 zeros here. One at -1, one at 2, and one at 4. There's my -1, there's 2, and there's 4. So I know this is coming down somewhere here. I know this is finishing up. Both of these are going up. So now I have to think about what's going on between -1 and +2. So I'm going to pick 0. 0 makes it nice and easy. And I get 8. But before, we were traveling all the way through this. We were coming down here. So what this actually did here, this actually turned up right away. It didn't go through the point. It's got to go up. This is the one that comes down and just kisses the graph. Okay, it didn't go through it. Right, now it's going to come back down. And if I pick this point here of x equaling 3, when I do my math, I get, I believe, I get -4. So this one's coming down and then going up. And that would be a sketch of this one. So this was different here. This was just a kiss. It didn't go all the way through. It just went there and went back up. This was one where we had 3 zeros from a quartic function. Hope this helps, and I'll see you next time.